Alright, for this next one we're going to look at a contradiction equation and an identity equation. First, a contradiction equation. Now the key to solving these equations is to manipulate both sides to look like different equations. Now the equations actually aren't different, they're going to be exactly the same. You keep equations the same by doing the same thing to both sides. So for example, let me show you really quick. Let's say I have x equals 5. Alright, if I multiply both sides by 3, I would get 3x, and this side I would get 15. Both this equation and this equation give me the same result for x. What if I added 1 to both sides? I would have 3x plus 1, and then I would add 1 to 15 to be 16. Still, I would be plugging in a 5 right there into that x. I'll be plugging a 5 into that x and then a 5 into that x. So my point right here is that this equation, this equation, this equation are called equivalent equations. And we get equivalent equations just by doing the same thing to each side. So what I'm going to do right here is I'm going to multiply this whole thing by a number so that I don't have any more fractions. Now if I multiply this whole thing by the same number, I'm actually just essentially multiplying this side by something and this side by something. But I'm going to save myself some writing, and I'm just going to write 12. The least common multiple for 3, 4, and 12 is 12, and if I multiply each of these fractions by 12, then we'll be able to cross cancel, simplify, and then there'll be no more fractions. So I'm going to make 12 into a fraction just by writing it as a fraction, 12 over 1, and I'm going to multiply it times this. If I look at this 12 and this 3 right here, I can see that I can cross cancel right here. That 3 would be a 1, and this 12 would be a 4. And then I would multiply 2x times 4 and 1 times 1. Let's see, 2x times 4 is going to be 8x, so I have 8x right there. And then I'm going to multiply this 12 times the next number. Alright, so we have 12 over 1, but this time the 4 divides, you can divide 4 by 4, and you can divide 12 by 4, so you get 3 here and you get 1 here. Again, we have 1 times 1 on the bottom, which is great, and then we have 3x times 3, which would give us 9x, so I just have a 9x right there. And next, the next thing I would do is I'd multiply 12 times the 2. That would be our next term. So 2 times 12 would be 24, so I'm going to write 24 right here. And then I would multiply 12 times my last term. These 12s both are divisible by 12, so you can divide them each by 12 to get 1s. We're left with 17x. No more fractions. Yay. On the left side, we simplify that side. We can combine those like terms right there to be 17x equals, and then on this side we have 24 plus 17x. And as we're trying to get the x alone, so we can see what x equals, we would move these x's over to one side. So I'm going to subtract the x's on this side, 17x's, and I'm going to subtract 17x's on this side, but lo and behold, 17 minus 17 is 0. We get 0 equals 24. That is a contradiction. Or you can say this has no solutions. This equation is not a valid equation. No solutions. This one over here looks pretty similar. Actually, I tried to write these to look similar so that we can see what an identity equation is. Alright, so the first thing I'm going to do is again multiply everything by 12. Alright, now we already did this once, and so I'll be able to go through this a lot faster. If I multiply the first one by 12, I get 8x. If I multiply the second term by 12, I'm going to get 9x. If I multiply 2 by 12, I'm going to get 24. And then I get 24 again. And then I get my 17x right here. Alright, so I simplify the left side by combining like terms to 17x's, and I see something right away. And what I see is that the left side is identical to the right side. Whenever this happens, we have all real solutions. This is the identity equation. It doesn't matter what number you pick. If you plug in a number to this x, and this x, again, it has to be the same number. Like if I plug in a 2 to all these x's, it'll work. If you plug in a 3, it'll work. If you plug in a 5, it'll work. If you plug in negative 10, it'll work. Since both sides equal each other, this is called an identity equation, which means your answer is all real numbers. let's say x equals for the fun of it. Alright, now what if you were kind of clueless and you just kept going? Well, if you kept going, you're eventually going to get a number that equals the same number. So you'll get a true statement. So let's go ahead and finish this here. Let's subtract 17x from both sides. You were just like not paying attention. You're like, oh, I'm going to subtract 17 from both sides. Then you realize, oh man, 17x minus 17x is 0x, so there's no x's on the left side. And then on the right side, the same thing happens. We have no x's on the right side, and we get 24 equals 24. Sometimes you also get 0 equals 0. In all these cases, this one, and this one, you're still getting all real numbers as your solution. So that's an identity equation.